Good to see you at MAHLO mCast. Now we had basis weight and moisture, and the third mCast today has the topic thickness. The product thickness of nonwovens can be very important, and it's not sufficient only to measure the basis weight. Due to the density of the web, the thickness can have very high variation even if the basis weight is very even. So we combine the thickness measurement, for instance, with the basis weight measurement, and we get the perfect information about the product. Let's jump right in. Hello and servus from Bavaria. Welcome to our new MAHLO mCast. In this YouTube channel, it's all about measurement, control and automation for moving webs. If you are new to our channel, don't forget to subscribe. My name is Matthias Wulbeck. I'm the product manager for web gauging systems at MAHLO. For more than 75 years, MAHLO has been active worldwide in the field of running fabric webs. In quality management systems, web process control, and web gauging systems, we have an experience over 25 years. So we know exactly where the shoe pinches and what solutions are available. In our mCast series on the topic of nonwovens, we would like to show you the online measurement and control of important parameters. Nonwovens are designed specifically for their intended use and must adhere to exact technical parameters to work perfectly in their final destination. These parameters are significantly influenced by the physical properties that result during production. The basis weight, the moisture content, and the thickness determine the decisive properties of the nonwoven. Today's topic is the thickness measurement on nonwovens. MAHLO is offering two systems for the thickness measurement. First one is the laser distance control. What we do is we have one laser element that detects the distance from the sensor to the material surface, plus a second sensor, a so-called eddy current sensor, is detecting the distance to a metal reference underneath the product. If you look at this example, we have the web on a reference roller and a single-sided laser thickness measurement. So the laser detects the distance from the sensor to the surface of the web, and the eddy current sensor detects the distance to the surface of the reference roller. So we have two values, the total distance and the laser distance, and if we deduct the laser distance from total distance, we get the product distance. Another method works very similar from both sides without any reference roller or touching the web. In that case, we detect the distance from the top and from the bottom of the web, and also an eddy current detects the distance between the two sensors. This is a very often used method for nonwoven material, but when we think about a very uneven surface on the product, then it can lead to very high variations in the measurement when the laser point gets into some open structure or some dense structure. This will cause a very fluctuating signal. So an alternative system is available. This is using a light beam over the top of a reference roller. This LED light beam creates a shadow on the roller where we have the web, and the width of the resulting light shows us the product thickness. And whenever we have a very open structured web with holes and thick and thin areas, this method gives us a big advantage and a more even measurement over the entire width. Here we see a scanner, a single-sided scanner, carrying the shadow sensor and the reference roller. And this can also be connected to an O-frame scanner, which is holding, for instance, a basis weight sensor, and then we put the shadow sensor on one side like this, and the web is passing over the reference roller. And in this case, we get the two measurements, basis weight plus thickness. And with these two parameters, we easily can also show the web density. Now you know what comes next. We take a look at it. Hello and welcome back to the MAHLO showroom. Today we have the pleasure to present our solutions for the online thickness measurement. And here we have a system with a single-sided scanner. We call it the UniScan, and we have integrated two different sensors for the thickness measurement to show you the advantages of both. Christian is with me today. He is our application manager. Christian, what exactly do you have prepared for us?
Hey Matthias, nice to see you again here in our showroom with our exclusive gauging systems we are using mostly for developing and request demanding of sample testing for our customers. Like you already mentioned, we examine here the thickness measurements for different kind of products. And on this application we do have two of our products integrated to have the measurement differences and also the advantages of each sensor. So we compare the results of the products of our customers. And here in the system we do have on the left side our DML line sensor system, and in the middle part we use right now here the DMS shadow sensor system. Both are able to detect and measure the thickness of the product.
And what are the specific advantages of these two technologies?
Thanks for the question. Here we see different kind of advantages from each sensor. For the DMS shadow sensor, for example, it has a very high accuracy. It can measure coatings or thicknesses down to 10 micrometer and is very accurate depending on the product. For the line sensor, it is very clear the advantage here is we can handle very rough and structured surfaces on a product. Like we can see here in the example, we do have some kind of bubble structure which indicates we have to handle those valley and hill structured surface. So this sensor is able to average, for example, those kind of differences in the structure and also have some other advantages.
And the line sensor is able to see the hilltops and the valleys separately. So we have the possibility to evaluate even the delta of the height of some structure on the web surface.
That's correct. So if we have a substrate foil and a printed structure, we are able to measure the minimum of the valley and the maximum of the hill on the structure, for example. That's correct.
Okay, so now let's take a closer look. Here on the laser sensor we see the red line, and this is the width of the measurement itself, and all structure points are detected within this range. And on the other side we see the green light band that takes a look over the top of the reference roller, and it detects the width of the shadow that comes from the web itself. Okay, Christian, just a few words to the screen.
Like all of our visualization of some measurements of the gauging systems, here we can clearly and on a fast view indicate how is the quality of my product. When we look at the upper part of the visualization on the screen, we can see here the width of the product and every indication of, here in this case, the thickness of the product. Where do I have on the product too much thickness of a coating? Where is it too much non-woven product, or is it too low? Both are indicated with some very fast viewed colors. Here we can see red means, for example, it is out of tolerance. I should adjust some settings during my production. On the lower part of the screen, we do see here the so-called heat map, also visualized with colors indicated. For red, it's too high thickness, or blue, it's too low thickness. This visualization also shows me for the length of the product, for example, the whole batch or the whole roll.
Okay, Christian, thank you very much. But we have one more for our visitors. And now we move to our assembling hall where we can see another thickness gauging system.
Yes,
let's go. So here we are in the MAHLO assembling hall where we make the web gauging scanners. So please excuse if it's a little bit noisy because we are very busy these days. And we have the nice opportunity to see a big O-frame scanner here equipped with a basis weight sensor plus a double-sided laser sensor to measure the thickness. And this is the thing we want to talk about with you. Christian.
So, like you mentioned, we do have here a nearly fully built gauging system built in with the DMLD thickness measurement sensor. Here we are verifying the last steps of the accuracy and also verifying the quality of the measurement. So herefore we put an example of a non-woven product between the sensor and prove that everything is fully provided before it comes to the customer's place.
The thickness gauge is detecting with a laser from the top and the bottom. So both lasers detect the surface of the material and calculate the thickness with this information. And the thickness profile again is shown on the video screen. So, Christian, would you like to explain?
Yes, of course. The basic information is that we use this kind of sensor mostly for plane surface for the products and can reach an accuracy of below to 50 micron. Also, a very special advice is that it's a contactless measurement, which is for some kind of products very necessary to have it. Here for this example, we are proving that the sensor is measuring correctly. We have created some folding edges in this nonwoven product that we can see if the thick parts of the product can be seen by our sensor. So let's take a look at our result screen where the measurement values are visualized. So here again, the visualization of the sensor is showing the valid measuring values. In the upper part of the screen you always can see the width of the product, and in the lower part of the screen you can see the length of the product, for example over your whole batch. Here clearly colored is the red color, which indicates that there is a thick part in the product, so it's too thick, or indicates also quite heaviness of the product. And in the blue screen with the color you can clearly see that you have thin parts in the product. So our folding edges, which are manually made into the product, can be verified during the measurement.
So today we could see the different solutions that MAHLO offers for the online thickness measurement. Whatever comes along, if we have a web with a very even surface, with a very delicate surface, or even with rough structures, we can find the right type of sensor for accurate and reliable online measurement. Thanks for watching and goodbye. Thank you very much for watching. Did you like the video? Then give us a thumbs up. Don't forget to subscribe to our channel. Then you won't miss any of our new videos. We would love to hear your comments and suggestions. So put them in the comment section. Don't miss the next episode of our mCast Nonwoven series. I'm looking forward to seeing you there again. My name is Matthias Wollbeck from MAHLO. Have a nice day and goodbye.